This is Margo. This is Sunday, September 2nd, 2018. And today I have on the line with me Robin Westenra from Australia. And we're going to be discussing some missing data regarding methane emissions and other greenhouse gases that we found on the CAMS website and also on the NOAA website. So welcome, Robin. Thanks for joining me today for this discussion.
Yeah, my pleasure. We've got a lot to talk about.
We've got a lot to talk about, and this will be, it's not live streaming to YouTube, but I will be uploading it to YouTube after we get finished, because people need to know about this. So we're going to start with your blog post now, and I'll just read it. I'll just go through it and read it, and then we can talk about it. And then I've got websites pulled up, and I found some things about the missing data, and then we can talk about what we want to. Okay?
Okay, that sounds fine to me.
And if you want to interject anything at any time, just feel free. So sure. Here we go. Methane emissions, missing data. And this is from Robin's blog post, Seymour Rocks. And his blog site is robinwestenra.blogspot.com. No Copernicus methane readings since Monday, 27 August. NOAA data whited out. This is the latest data from CAMS Copernicus, which was able to capture. It shows methane emissions off the scale, as well as high readings in East Siberia, which go into the Laptev Sea. And I showed this in my last Arctic sea ice update. I did show this, and that was the last data that I had, because the date of that show was a couple of days ago. Since then, the data has not been updated. It was set out in a way I've never seen before. Now today, that data has disappeared, and there is no data whatsoever available for methane emissions as below. And that's what I get when I go to CAMS as well, for methane and also carbon dioxide. In fact, the menu for both methane and carbon dioxide have been whited out. Note that data for carbon monoxide, aerosols, and ozone is still available. And there's the drop-down list for the filter results, and you can see where it's just whited out for carbon dioxide and methane. And we can look at that on CAMS as well. Given that readings before the data disappeared were so high, it is very strange, and whilst I would like to think that there is a fully innocent explanation for this disappearance of data, I am suspicious that it is indeed conscious and there may be some sort of cover-up. Everyone has been commenting on the increases in emissions. For reference, here are the very informative reports on methane Margo has been doing. And then these are just some videos that I've done on the different greenhouse gases. And then you switch to missing NOAA data. As if that was not enough, here is a previous reading of global methane emissions from NOAA. Note readings were up to 2,686 parts per million. And that's actually parts per billion.
Oh, yeah, sorry, yeah.
Yeah, that's okay. Coincidentally, we have been seeing data such as the following, which registers a fall off of methane emissions while large areas of the globe are excluded. And this is from August 30th, and this is from the Met-Op satellite too, in the afternoon. And so this white area is no data. All that white area, it shows that there's no data coming in. Is it just me, or do others smell a rat, a cover-up of something? Do you want me to read this last part?
Oh, no, that's okay.
Okay.
That's not relevant.
Yeah. Yeah. Well, people can, if they want to read your blog post, they can go there and see the
Yeah,
rest of it.
yeah.
Now, a couple of things that we're going to look at specifically besides the CAMS website. I kind of delved into the NOAA website today. I hadn't really looked that closely at it because it just seemed really complicated and hard to use, and I really liked CAMS because it was so easy to just click, 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 and you get everything that you want. But I was forced to go in and, dig in deep and do my research on the NOAA website since all this came up, to kind of see if I could make heads or tails of all of this. So first of all, what I have up here, I'm going to go to, this is Sam Carana's Facebook page, and this is where he uses the NOAA website a lot to get his methane and temperatures and all kinds of readings. And there are different programs, or they call them products, on the NOAA website that you can use, and each product will produce results of different kinds of substances or greenhouse gases or this or that. So we're going to go over that in a minute because I looked at all of that. But first of all, right off the bat, I notice, let's get this picture a little larger. I noticed that this is from the NOAA website, and it's mixing ratio of methane, and it's, I'm trying to point, but it's graying out. It's MEDOP Satellite 1. This is what it means, and it's from August 31st in the afternoon. And these satellites, they take readings in the morning and in the afternoon. So there's going to be two available for each day. There are two satellites. There's a MEDOP 1 and a MEDOP 2. So you have 4 available satellite readings from each day. All right. This up here is the where it is in the atmosphere that we're looking at this reading, and this is at 469 millibars, which is equivalent to about 5 kilometers above the surface of the Earth. Now in CAMS, we usually look at the surface level readings, and as you go up in the atmosphere, for methane and carbon dioxide, the readings tend to get higher because these greenhouse gases start mixing as they get higher up in the atmosphere, and they start spreading out instead of being just localized on the surface. And so, first of all, right off the bat, I see that it's not at surface level, and if you're reading it in millibars or the HPA, that's the hectopascal scale, it's 1,000 millibars is surface level. That's what I've learned. And now, according to this, it says the range. I wish that wouldn't show up like that, but if you'll look over here in this top left corner while I'm talking, the range scale that they measured was 1520 to 3369 parts per billion. And the mean.
Yeah, and that's unprecedented as far as I know.
It's unprecedented, but you have to remember it's 5 kilometers above the surface. Yes. So that's not unusual. I don't think that's unusual to see it that high, that far above the surface. I mean, I haven't been really following this NOAA website that much. What were you going to say?
Well, I mean, I can say, because I've been following it for a wee while, that I mean that's the level that Sam Karana normally quotes, and usually, the high, because he always quotes the the peaks, the highest level rather than the average, and the averages that he's been given, have been sort of the nature of 2,300 or 2,400 or something like that. So
Right.
I don't think I've ever seen it as high as into the 3,000s.
Okay. So, we could be having a methane event going on. I don't know. And like we were chatting, it's doubtful that we really will know if we're having a methane event because they don't want us to know.
Yeah. Well, I've got an immediate question.
Okay.
About this, because they quote this level of 3,000 or whatever it is, parts per billion.
Right.
But a lot of it is whited out, so that implies that there's no data. So does that mean that if there was data, that the levels should be higher?
I don't know.
Yeah,
It
well, that's right.
could
That's
be
right.
higher. It definitely could be higher.
I'm just posing the question.
So he says over here, methane reached peak levels as high as 3369 parts per billion on August 31st, while mean global levels were as high as 1903 parts per billion, as recorded by the MET-OP satellite 1. So that's the reading here. The MET-OP 2 satellite recorded levels, so that's a different satellite that I was telling you about.
At different times of day.
Yeah, I'm going to show you in a minute how to find all of this stuff. Recorded levels as high as 2485 parts per billion and 2458 parts per billion in the morning, respectively, the afternoon of August 31st, created by Sam Karana with NOAA images. And then you have the color scale down here, and the purple is that really high level. So, and then it goes down. So anyway, we'll look at that more in detail on the NOAA website. But that's a little introduction of what we're looking at. So we're trying to figure out if we do have a methane event going on, where's the data? Is there any data that we can find? And I did find another sounding product on the NOAA website that does track methane data, and we're going to look at that. And it looks like that data is complete. It doesn't have a whole bunch of white blotches in it. So I don't know what's going on. I really don't, but it throws up a red flag to me, quite frankly.
Yeah.
Because along with all the other things going on in the world geopolitically, and it's Labor Day weekend, and it's a holiday weekend for the U.S., and a lot of times things do happen during holiday weekends over here. So there you have it.
And is it a coincidence that two major separate satellite systems have got missing data?
I know.
At the same time.
Well, but there might be a reason for that, and we're going to look at that in just a second. Now, first of all, I'm going to start with, here's the NOAA website with the IASI sounding products. And this is from, this is all the trace gases products derived from the infrared atmospheric sounding interferometer, or the IASI, and the NOAA Unique Combined Atmospheric Processing System, or NUCAPS. And it says they're not validated yet by the science community, and users should use them with precaution and at their own risk. These products will be updated soon after a thorough science validation. They need someone to edit their website. That's not through. That should be thorough anyway. And it tells a little bit about it. The IASI is a hyperspectral infrared sounder residing on the European Space Agency's METOP series of polar orbiting satellites. You got all that?
Yep.
This is from the European Space Agency, one of their satellites. Now, CAMS is out of the European Union as well. So considering that this data is coming from, all of it's coming from data, all this data originally is coming from the European Union, I'm thinking this blackout could be on their end, not from NOAA's end. So now we scroll down, and on this product, we have data for, we have data for 3 days. Yeah. Because, yeah, they have it for yesterday, September 1st, Friday the 31st, and Thursday the 30th. So, and then these are all of the things that you can look at in this product. You can look at temperature, first gas temperature, mixing ratio of water vapor, ozone, carbon monoxide, carbon dioxide, and methane. And then you can look at surface properties, all this stuff, okay? So there's a lot that you can look at in this one product. And it tells all about it if people want to take the time and read about it. And so when we go to methane, so what was that date from Sam Carana's August 31st, right?
Yeah.
August 31st, okay. So where was I? Here I was. So if we want to go to August 31st, we've got it here on the drop down button, and we click go. And now it says Friday, August 31st, retrieval parameters. And we've got METOP 1 and METOP 2, and those are the two different satellites. And I don't know if they cover different parts of the Earth or what, but let's just get going here with methane. And we're starting in the morning, 0 to 12. That's a Zulu, but anyway. 0 to 12, and look at all these choices. You have all these different choices, and what these are different levels of the atmosphere, readings of the, and so when you first come here, it's like, oh my God, which one do I choose, okay? And if you go all the way down to the bottom, that's at 1,000 millibars. So this is at surface level.
Yeah.
Okay. And so here it shows the range from 1612 to 1953 parts per billion. And this was in the morning of August 31st with METOP Satellite 1. And so we can see the scale down here. This is parts per billion. All this white area, it says, is no data. But we can see, let's blow this up. Well, let's get our scale first. Down here, 1500 is like orangey red, and then this would be, okay, we're going up to 1953. 16, 17, 18. I guess this red would be like the 1953 area. This dark red, like up here, all of this up here would be 1953. All right. So if we zoom in, here's what we've got. We can see a lot of that 1953 methane being released up in the Arctic. Here's Novaya Zemlya. Here's Norway. Look at all of this off the Norway coast. Isn't that something? Here it is over Europe and Russia and Siberia, and then all of this is over the Laptev Sea and the East Siberia Sea. And then it's gathering in the Arctic, and then there's more over the over Alaska, and then this part is whited out with supposedly no data. And then what I find curious is all this methane coming up over the ocean. You know, I don't know if I haven't spent that much time looking at the NOAA readings on methane. The CAMS readings on the surface level, they really zoom in on what it is at the surface, and you don't see much coming up out of the ocean. You don't see much over the surface level of the ocean. So I don't know the discrepancy here, why we're seeing it over the ocean instead of over the land so much. So, you know.
And then also with Scandinavia, I see too. You know, it's in the seas around, but not, you know, the CAMS stuff shows.
There's not much over the lands, but so it might be that it's really more in the air than really but anyway, it's got to be coming from somewhere. It's not just popping up out of nothing. Okay, does that make sense to you?
Yeah, I think so.
And look at this gray. It says QC fail, quality control fail. So all the gray means it's a fail. So it may be that there's really methane on all these areas that are gray.
Yeah, I got you. So that's not no data.
But maybe the readings didn't come in right or something, and their quality control people said, no, we're not going to allow that through to the public domain.
So it might be quite good to look at the same data for a different day.
Yeah. And so there may be methane just covering up the whole damn world as far as we know. Probably is. So then, now when you go here on this one, that's 1,028 millibars. So that's a little below sea level. So you have less data. And then here, that's like 1,057, and that's more below sea level. So then as you go up in these numbers, as the numbers get lower, you're going higher in the atmosphere. So this says 459 millibars. Let's look at that. That's actually 451. I don't know why that is. But let's see if we can find Sam Karanis. What was his 469? Something like that. Uh-oh, I went too far. See, these are not exact. 487. Here it is. Here's his 469. So this is his from METOP 1 in the morning. Does that look like his?
Yeah. So what kind of
Oh, his was in the afternoon, but this
yeah,
is
yeah,
close enough. You get the idea.
yeah,
Uh-oh, where am I? I forgot where I was. Oh, here I am.
yeah.
Go
So
ahead.
what really kind of is obvious to me is whereas those levels were lower, they were in the red at surface level. Then you've got these very high magenta or pink
Right,
uh, readings up
right.
high in the atmosphere, and that seems rather strange to me.
Well, it doesn't really to me because methane is a very light gas and it rises quickly. And and what I've seen on CAMS when I change the level and I go up further in the atmosphere, the levels do get higher. I've seen that
Okay,
on CAMS, so that
yeah,
doesn't surprise me.
okay,
But I don't know why Sam Carana uses the 469 millibar reading. I really don't. Because other climate scientists like Paul Beckwith, when he does his videos on methane, he uses the surface level reading.
right. Also, when he's quoting the NOAA, or
I don't know if I haven't really seen him use NOAA. I've seen him use CAMS.
yeah, right,
I don't know. I haven't been that looking that closely. I just seriously, until today, I haven't paid much attention to the NOAA data, but I will
yeah,
now because I had to figure it out. And the more I study it, the more I'll learn about it. So there's that. And if we go back to the 30th, what you'll find is that we had more complete data in the morning on the 30th, and then
hmm
the data started dropping out after that. And this is at all the different levels down through the atmosphere. And these are all the same because it's all coming from one satellite image, okay?
yeah,
And we can see we have data missing here and data missing here. And these white spots, I'm thinking, is where they flattened out the world view because the world is round and then they
yeah,
have to flatten it out. And so these straight lines, I've seen those like all the time. And that's where they have to flatten it out and go from round to flat. And so you're going to have a little bit of missing data just with these straight lines, but this is not normal with these larger areas, and
yeah,
down here is not normal, right?
yeah.
Okay.
And there's still a lot of grey there too, isn't there?
Oh yeah, QC fail, right. And then what I found was in the afternoon picture, look at all these white spots.
Yeah.
I'll go down here, the surface level, and all of a sudden you have all this missing
Wow.
data.
Yes, yes, yes.
So it started on the afternoon of August the 30th, is what I found.
Yeah.
That's when the data started being missing. Now, let's look at the METOP2 satellite. Here's METOP2. Now, this has pretty complete data for the morning, as you can see, right? This doesn't look
Yeah.
much different than METOP1, does it? Except this is in the afternoon. We have some missing data here and here and here. I guess this straight line across, I guess that's missing data.
Yeah.
But then let's look in the afternoon on MET-OP2. And there you go. That's where you started getting the whole northern hemisphere blacked out. We'll go back down here to surface level. Look at that.
Yes.
And that's what everybody was getting up in arms about. And they thought it was just on methane, but it's not. And I'll show you that now, because I was thinking if it's just methane or carbon dioxide, then these other levels wouldn't show up, right?
Yeah.
Let's look at temperature. And it looks just like what we got on methane as far as the area that we're getting. I'll just pick this one. See? Doesn't it? So, and then let's look at water vapor. Let's go to water vapor in the afternoon on MET-OP2. See, it's the same blackout. See?
Ah, yes, over the whole. Yes, yeah. No, I've got you.
So it's not just methane and carbon dioxide. It's all of the things that they're measuring with this product. I went through all of them. Ozone, everything.
Yeah.
And actually, they've got the wrong image up on ozone. They've got AM. If you look up here, this is the AM thing, but it's under the afternoon thing.
Yeah, right.
So they're not perfect either. I mean, they have people putting in this data and, doing data entry, and it's easy to make a mistake. I've done a lot of data entry. It's really super easy to make one mistake and to screw up a whole image. See?
Yeah,
this is carbon monoxide. So we first of all dispelled the theory that is just methane being blocked out. It's everything from this product. It's called the product, okay? Now, the next page I've got pulled up is special bulletins, and it's still on this same NOAA website. I can't remember how I got here, but this is, I clicked on all of them, and this is the one for pre-product okay. If you click over here, they put out these notices whenever they're going to be calibrating, or there's going to be a deviation in the data or something like that. And you can get on their mailing list and get their notices. So this is, this is their public website. So nothing here is secret. So they'll send out notices. So here's a notice that was issued on August the 15th. And it said, Administrative NOAA, MET-OP A2 and MET-OP B1. So those are those MET-OP satellites, monthly visible calibration update, and on and on. And it says visible calibration update for the month of August 2018, time issued August 15th. Day impacted all products from channels 1, 2, and 3A. Time and date of initial impact 14th. Time and date is expected end until next month's coefficient update. Length of outage NA, not applicable. Details and specs on August 14th, 2018 at approximately 12:30 Zulu time. The following update of the calibration coefficients was implemented in the level 1B processing for NOAA 18, NOAA 19, METOP A2, and METOP B1 for the month of August. These coefficients are intended to be optimal on August 28th in the middle of 2 scheduled updates. So they calibrate, and they do this every month. And so it says the coefficients are optimal on August 28th. And so with each of these reports, they'll say like what date it's optimal viewing. And so on all these other dates, it's like, you know, we're not guaranteeing the coefficients. And so that's going to be, I think that's going to be their out for why there's all this missing data. Know what I mean?
Yeah, I do, but I mean, it sounds from what I've just sort of seen, if I can kind of, to the extent that I understand it, that they've done their calibration in the middle of August, and then as of, what was the date? The 28th, everything should be back to normal. Is that
well, they're in between calibration periods, and I think they cycle through or something like that.
Yeah.
So anyway, now I'm going to hop over to all of the sounding products, and this is still on the NOAA website, and this tells in detail like what each product delivers. And so the one that we've been looking at is this one, the IASI sounding. All right.
Mm-hmm.
And it says the infrared atmospheric sounding interferometer on board the European METOP satellite was launched on October 2006. IASI produces temperature and humidity profiles with vertical accuracies of 1 degree Kelvin and 10% per 1 kilometer layer respectively. The first priority of the IASI processing system is to generate radiance products from data ingested in a pipeline mode from EU METSAT. These radiances undergo subsetting, principal component analysis, reconstruction, and global gridding. Subsequently, these radiance products are distributed to users as BUFR, NET, CDF, and binary files. All levels of data products are made available at the user-specified locations as subset files and as gridded subsets. And then you click there, and then you go to where we were. That's how you get to that. All right?
Yeah.
Then this is MIRS sounding is microwave integrated retrieval system. But the one I looked at, the other one I looked at was the NUCAPS, this one. NOAA Unique Combined Atmospheric Processing System was developed to generate 1. Spectrally and spatially thinned radiances, 2. Retrieved products such as profiles of temperature, moisture, trace gases, that would include methane,
Yes.
and cloud-cleared radiances, and 3. Global validation products such as radiosonde matchups and gridded radiances and profiles, etc., etc. So we can click on Global Gridded Images. We go down, and we've got a week's worth of data here.
Mm-hmm.
All right, rather than 3 days. We've got a week's worth here. And then here are all the things that we can look at: temperature, water vapor, liquid H2O, ozone, methane, carbon dioxide, carbon monoxide, sulfur dioxide, nitric acid, nitrous oxide. So let's go to methane. And this is for 24 hours. And here it is. So this is set up a little different. We have fewer pictures to choose from. And this is much easier to read in my book because this is set up by NOAA. So we go down to 1,000 millibars, so that will be surface level. And I've seen this before. I've seen pictures like this before, or images, you know, in different scientific papers from different people, and I didn't know where it came from until now, because a lot of them won't reveal. They'll just say, well, this is from NOAA, but they don't say which data set it's from. So it's from this one.
Yeah.
All right. And so this is, the top picture is from the morning, and the bottom picture is from the afternoon. Now that's very simple. And then up here, okay, here's your globe. We don't really have missing data except for a little bit of white areas, right? And then then it tells below the picture, the minimum is 2040.31 parts per billion. The maximum is 2146.82 parts per billion. So this dark off the chart at this little tippy point is 2146 parts per billion. And we can see that a lot of this Arctic area in that zone, isn't it, Robin?
Yeah,
Isn't
yeah,
that something?
So can we look at the same thing, but from the same level, the 5 kilometer high level that Santa uses?
Yeah,
That would be interesting.
you bet. And then here's the afternoon, and it was a little higher because after the sun had been up and everything. The minimum was 1,009 parts per billion. The maximum was 2208 parts per billion. And the same thing. And look, this is covered, this whole area from Europe up is covered up. And what we're seeing, the level over the oceans is less. And this looks more normal to me. Yeah. Except, you know, I know that the readings over land will vary depending on the time of day as well. Because
the thing that boggles my mind is with all of these, whether it's CAMS or whatever, you know, that they're all in those high, you know, the highest level, you know, and yet there's no differentiation. I mean, they should be changing their color schemes.
You would think.
Yeah.
So let's look at 487. That's 487. That's pretty close to what Sam Carana's was.
Yeah.
All right, let's zoom in. And our lowest is 1601, and our highest is 2258 parts per billion. Now this is from yesterday. That's not from the 31st. We can go back to the 31st.
Yeah.
And we can
those are the sort of levels that I've been expecting, you know, of recent months that I've sort of seen.
We can see that there's less in the Arctic on this at this level.
Yeah.
And it's more beginning to be more evenly distributed. Because what happens, it starts breaking down and being distributed as it goes up through the atmosphere. Let's choose August 31st. for methane. And let's choose this 487. Now we can see that we had more. It was a little higher up in the Arctic.
Yeah.
See, that day. The range is 1582 to 2326. So that's quite a bit different than Sam Carana's reading.
Yeah, well, it's not his reading, is it?
Well,
satellite.
That other product is from the EU, and this is NOAA.
Yeah. Right. So which satellite is this?
Well, let me go back and look at it. I don't remember everything I read, unfortunately. Yeah. This is the infrared atmospheric sounding interferometer and the NOAA unique combined atmospheric processing system. So it's a sounding system. It's an infrared, I'm not sure it's a satellite.
Yeah.
It's some kind of infrared sounding system.
Yeah, that doesn't mean much to me, but yeah.
That's all I know.
Yeah.
I mean, I'm doing my best here to, try and get a PhD in this stuff and, a month or two, period. So, let's see. New caps. The most information that you have about new caps is right here. Okay, these products are devised from the cross-track infrared sounder and advanced technology microwave sounder currently on board. Here you go, the Suomi National Polar Orbiting Partnership, or SNP, satellite, and later will be available from the Joint Polar Satellite System. So this is a different satellite than the other one. So that's why we're seeing the different data. It's from a different satellite.
Yeah.
Okay. So that's the problem with trying to figure all this out, because you get one model and it's one satellite, you get another one, it's another satellite. It's like, well, which is which and which is better and what's the right reading? And it's just hard to know, Robin, isn't it?
Yeah.
It's just so confusing. And, we just have to keep exploring and keep an open mind and not get locked into one system and one idea and thinking that, oh, this is it. And because when the shit hits the fan, I don't think we're really going to know it immediately.
Yeah.
I think we'll have a blackout of everything.
But it also shows that you just can't kind of come to hasty conclusions about things,
No, you can't. You have to look at all the data and you have to dig deep.
Yeah.
And then you have to take it all with a grain of salt and realize that this is their public website. And they probably have an internal website that's different. But this is what their public website looks like.
Yeah.
And we're not on the inside. That's a closed club and we're not members.
Yes. But I wonder what the potential is for them to manipulate data. I mean, if there was inconvenient data coming in.
I don't know. I mean, Richard Hoagland's book that he wrote about the moon, when he worked for NASA for a while. I think he was a private contractor studying satellite images from the moon, and he did a whole book about all the stuff that they would just airbrush out from NASA. there were structures on the moon, geometrical structures and domes and spires and all kinds of stuff that were in these images. And then, you know, then they'd send them to their other department to airbrush out all that stuff to send to the public. But he got those images because he was working on the inside and he was analyzing them, and then he put them in his book. I can't remember the name of it. But I got the book, I read it, and it was like, oh my God. And, you know, they have the ability to take away any data that they want to take away.
Yeah.
And to skew it any way they want. And it doesn't matter what we do, if we do an uprising or what, it doesn't matter. We're not going to get it if they don't want us to have it. We're going to get the data that they present to us. And all we can do is the best that we can with the data that we can find in public domain, and then use our discernment and keep questioning and not just take things at face value and not accept one person's saying this or that and accepting it as truth. You know, we have to do our own research and go beyond what one person is saying.
Yeah, that's right. I mean, we might be able to discern the very early stages of something which they might go on to suppress. I mean,
yeah, if we caught it before they whitewashed it.
Yeah.
Because remember the Roswell incident with the UFO crash in 1947, there was an actual article in the Roswell newspaper about the crash. Yeah. And then that was gone. That was taken away.
Yeah, and then there were photographs, weren't there?
Oh yeah, there were photographs and everything. Yes. And then they got the orders from above saying that was you're going to report saying it was a weather balloon. And so that was the official story. Yes. And I know from my years of dealing with the UFO research, they do that all the time because the government, these are areas that the government does not want us to delve into. Abrupt climate change and UFOs. I'm telling you, these are hot topics.
Yeah.
Okay, we're going to hop over to CAMS now. And I was just investigating some other areas to explore on CAMS since methane and carbon dioxide weren't up. But I'll show people when you go, this is the charts view. Let me open this up. This is the charts view. And when you pull down the filter results, you can see methane is whited out with no data, and carbon dioxide is whited out with no data. And someone asked why this says forecast. Let's go over that real quick. Okay?
Yeah, that's right.
The reason is...
So he was saying, wasn't he, that all CAMS provides is a forecast. They're not real,
No, they do. They do provide real data.
Yeah, that was the point. That was
right. They do provide real data, and otherwise they can't forecast without real data. And so let's look at ozone. And when that pulls up, it defaults to total column. And the base time, these are the days that we have data for. It goes back 5 days. And so if you run the movie with the base time of Wednesday, August 29th, it will show actual data. Okay?
Yeah.
Through today. But like if you set the base time for today, Sunday the 2nd, then this is actual data for today, and then when you run the movie, the pictures that you're going to see over here starting on Monday, Tuesday, Wednesday, Thursday, that's forecast based upon the previous data that's uploaded in the system.
Yeah.
And then when you're in the catalog view, that's a little bit different. For instance, we'll go to sulfur dioxide. Usually sulfur dioxide is current. Then you go to the plots view. And down here, this has more days. And it starts with the 29th. And then, so this is actual data. Then you can see the days going by through the 2nd. And then once you get into the 3rd, that's the forecast period.
Mm-hmm.
Okay? And so they forecast the 3rd, 4th, 5th, 6th. So they forecast forward 3 days. So you've got a whole week of here. So the first 5 days are data, and the last 3 days are forecasts. So that's how that works.
Can I interrupt?
Yeah.
I just noticed that the battery reading is very low, so I'm going to have to kind of plug this into the mains.
Okay.
So I'll do that, but you keep on talking and explaining this.
Okay.
While I do that.
I want to show everyone ozone at the South Pole, because we've got some problems at the South Pole, and the ozone hole is growing, whether people know it or not. And the sun has started coming up over the South Pole. It's just peeking up over the horizon. And this is very disturbing. So I'm going to load up this movie. And we're going to let that load while Robin is plugging in his computer. And so we're going to look at the ozone level over the South Pole. It should be starting to come back, I'm thinking, since the sunlight is up a little bit, and it's starting to warm up down there. And what we're seeing are lower levels that I've not seen over the South Pole. And this is base time starting from last Wednesday, going through today, and this is actual data. And it actually gets down to this blue, this kind of brighter blue reading of 150 Dobson units. That's equivalent to 1.5 millimeters of ozone level through the atmosphere. And the lowest NASA has ever recorded on the ozone layer, I think, was like 98 Dobson units. And it was in November one year. Are you back with us, Robin?
Yeah, I'm back now.
Okay, what I pulled up is the Antarctic with the total column ozone level to show how the ozone hole has grown. And this doesn't look like the pictures you've seen before, does it? You see that?
Yeah. Wow.
Yeah, and I was explaining that the hole is, it's much thinner, and it's gotten so much bigger because here's the Antarctic, and this aqua blue is what we're used to seeing as the lowest reading, and that's 220 Dobson units. And then this kind of purplish blue, which is this color here, is 200 Dobson units. And then this blue this darker blue, is 175 Dobson
Yeah.
units. And then we're getting this other blue at 150 Dobson units. And this is the lowest I've seen it since I've been watching it. And I was saying that I thought that we should be getting the ozone some higher readings in the Antarctic since the sun has started coming up down there.
Yeah.
They're actually getting some light down there. They're coming out of winter. They're getting some light. And so what do you think about this?
Wow.
It kind of flips me out, doesn't it, you?
Yeah. Well, it's highly significant for this part of the world, you know, where.
Oh, yeah. And then I discovered that, now I'm going to switch it to surface level, because I was saying I didn't know why surface level ozone was increasing in the Antarctic, but then I realized, you know, they're starting to get some sunlight. And so the sunlight is interacting with the atmosphere and creating some surface level ozone. So I'll just show you that. And it's going to be really interesting to watch this as the sun rises and to see what the levels get to as the sun rises, and then they're in full daylight for months on end. Look at that.
Presumably we're a couple of weeks away from the sun rising.
Well, it started coming up. I found a blog. I found a really good blog. It's from this guy. He's a professor. He's out of the UK, and he specializes in studying polar ice, and he teaches environmental sciences on some open university, and he's very knowledgeable. I really like him. And he's showing the sun starting to peak, and they actually start getting light before it comes up on the horizon, because the sunrise happens for a few weeks, you know, and the light starts coming up, and every day gets a little bit more. Just like in the Arctic, it's starting to get darker as the sun is lowering towards the horizon. And then it all switches at the fall equinox, September 19th or something like that. Right. And then it all switches, and then the northern hemisphere goes into its winter, and the summer hemisphere starts going into its spring. Or the northern hemisphere goes into fall and winter, and then the southern hemisphere goes into spring and summer. And then they'll go into days of no more darkness. It'll be daylight for months on end.
That is fascinating, looking at the world view. You could see these dark areas, you know.
I know.
Yeah.
But so this would explain the surface ozone levels of what we're seeing increasing, because the sunlight's coming up. They're getting sunlight to interact with the atmosphere, is what I'm saying.
Yeah.
That just fascinates me. It's just so interesting. So I think we've kind of covered the issues today. Is there anything else you want to go over before?
No. I mean, we've really covered that. You know, that sort of that basic thing of kind of the missing data, and I guess with CAMS, we'll just have to wait and see if, you know, the start of the working week will lead to a correction.
Well, I'm a member of CAMS. Well, I mean, you know, where you can go in and ask questions and stuff.
Okay.
I think I'll send them an email and ask where the data is for methane and carbon dioxide, and they usually answer within 24 hours. And so I clicked on filter results for methane, and this is what comes up. Chart could not be produced. So there you have it.
Well, I think this is going to be very interesting material for people. It's very new.
Yeah, and this will give people something for people to think about, and you know, we'll have our campfire chat this Thursday, and maybe we'll have some more information by then. So
yeah, this indicates to me that, you know, the whole thing with data and things is a lot more complicated than we think. And I've always had problems with people who sort of just cite their own authority. They don't really cite the data.
Right. And that they don't give links to where they actually got the data from.
Yeah.
You know, because, you know, I'd like to look that stuff up myself.
Yes.
Frankly. Now, and see, here's the catalog view, and on the ones where you have data, it shows up a picture over here on the left, but as you can see, greenhouse gases, nothing.
Yeah.
Methane, nothing. Yeah. Carbon dioxide, nothing. So,
I mean, that's strange with the carbon dioxide, because I mean, that doesn't change very much. You know?
No. So why would they black that out? You know, I don't understand. It's beyond me. So we'll, you know, unless you have anything else to go over, Robin.
No, I don't. I think that's been very, very clear, and I've certainly learned a lot.
Okay. So, thanks for joining me. I've really enjoyed discussing this with you today. And, you know, when you're asking me, well, do you have this data and that data? And I'm like, yeah, it'd be easier just to do a stream with you and show it to you.
Yeah.
Rather than send you links and try and type explanations, because, you know, you really can't explain it just in writing. It's just easier to see it.
Yeah.
It's just easier to see it. Well, before we sign off, I've got sulfur dioxide pulled up here, and we've got more emissions because we've had a lot of earthquake activity. Here's Vanuatu, and you know, we've had earthquakes up here at Papua New Guinea, and all these other areas. I mean, it's all this ring of fire is just so active with earthquakes, and so that's causing volcanic activity as well, and also with the earthquakes, sulfur dioxide is released. So
I know that was one thing, because Robert Fanny in his interview, he was ascribing a lot of the methane to forest fires in the tundra, and well, not forest fires because there's no forest.
Tundra fires, yeah.
Yeah, and I'm just wondering if we can see signs of that.
Well, we can't pull up methane.
No, but it won't be methane, will it? There'll be other particulates.
Oh, you want to look at ozone? Yeah, ozone is a
no. Ozone or particulates?
I found something else today that will show that. It's over here under aerosol depth with black carbon, and I was going to do this in a separate show, but this is perfect for what you're asking. Now, these are aerosol forecasts. This is combined. It defaults to this whole combined optical depth at 550 nanometers. All right. And then you can look at dust aerosol, sea salt, biomass burning, and sulfate aerosols. So let's look at biomass burning. And let's see what we can see.
Oh, it's just that tiny area up at the top.
And this is optical depth. Let's go back. Let me go down. Let's go back to the beginning of the cycle here. Let that load. You can automatically see Norway. You see that red there in Africa? Apparently they're cutting down trees and burning areas in the southern area of Africa. Here it is. See it red popping up here in Siberia where I have my pointer. There it is.
Oh yeah, that's lower down. That's more.
Yeah, that's slowing down.
Boreal forest. Oh no,
Yeah.
up the top.
And up here, here's some more. That would be
that's
more
what he's talking about, isn't it?
Up by the edge of the northern edge. And then we can see up in Canada, and then down here in California, and down here in I can't tell. That's right at the southern end of California going into Mexico. Look at this in Africa.
Wow.
Isn't that something?
Well, they must be just like burning stuff off like there's no tomorrow.
It's awful.
Yeah.
And I was so fascinated with this new area.
Now that looks like the Congo or somewhere.
Yeah. Actually, the Congo is up here.
Further up.
Kind of up here. This is a little bit further down, but they're cutting down all the forests and burning them and gonna make farmland out of it.
Even in South Africa itself.
Yeah. I want to show you. This is so cool. You can look at all these different things. And dust aerosol, you can see, this is from the Sahara Desert, how the dust is blowing across the Atlantic. We can look at that.
And in the Gobi Desert. So.
That's loading up. And look up here. This is in China.
Yeah, that's the Gobi, isn't it?
I guess, yeah. And look up in India and here in Saudi Arabia, in all these desert areas. Look at this plume coming across the Atlantic Ocean. So we're getting that.
Yes.
And eventually it spreads out and goes up into the atmosphere all the way up. Eventually it goes around the world. Isn't that interesting?
That is fascinating.
I love looking at this stuff. Look how that red, that high level is spreading out across China and just coming across.
Yeah.
No wonder their air is so bad.
And then all the methane.
I know. Well, you combine everything together. It's a wonder we can even breathe and function at all.
Yeah. Well, that's why they have to import air from New Zealand.
Yeah, they have to breathe it out of a can.
Yeah.
So, and this is why people are so much sicker.
Yeah.
And it's not going to get any better. And, I mean, we've got more respiratory illnesses, more heart illnesses, more cancers, more early Alzheimer's and more autism. And it's just, oh my God, nervous conditions. I mean, we're so polluted and there's no safe place. No safe place. It's everywhere.
Yeah. Oh, well, on that happy note.
Let me click back over to TalkShoe. And so thank you so much for joining me today, Robin. I've so enjoyed having this chat with you, and I hope it enlightened everybody as to a little bit more of the truth as we're just going forward to discover what we can. So until next time, my name's Margo. My website is margoshealingcorner.com. Robin's website is robinwestenra.blogspot.com. Go in peace. Time is short, folks. Get your spiritual houses in order. God bless everyone, and goodbye.